I'm a master student in bioresource engineering, and today I'm going to present you my thesis, sensing the carbon sequestration and recalcitrance of biochar at varying temperature and different feedstocks. The climate change is now a global issue because of increasing levels of greenhouse gas emissions, and burning fossil fuel is one of the main anthropogenic activities that contribute to increase the CO2 emissions. And biochar is considered as a carbon neutral resource that does not increase the CO2 levels. And because the plants absorb the CO2 in their growing processes, and the biochar could sequester and store the carbon in the soil for hundreds of thousands of years, because it has a large content of aromatic carbon. And I have two objectives. The first one is to study the effect of the temperature on the amount of carbon in the biochar from different feedstocks. Because the temperature and the nature of the feedstocks are the two major factors in determining the thermal and chemical properties of biochar. And the second one is to assess the recalcitrant capability of biochar by measuring the volatile matter content and the ratio of the hydrogen to carbon and the oxygen to carbon. It's experimental setup. First, I have a PID to control the temperature, and the SSS to provide the power, and cylinder heater and stainless steel used as a pyrolyzer, and thermocouple to measure the temperature of biochar, and two water-cooled condensers and two ice-cooled flask to connect the bio-oil. Then I will move on to the raw material and the methodology. I will use rice husk, wood chips, and cotton manure to do the pyrolysis. The first step is the feedstock preparation. It includes the drying and grinding. After drying the raw materials in the oven for 24 hours at 105 degrees Celsius to remove the moisture, and grinding them into 2 millimeters. And then the materials will be placed in the reactor to do the pyrolysis under these different temperatures. And each experiment will run for three times. And after reaching the terminal temperature, the pyrolyzer should be cooled down to the room temperature. And then I will measure the biochar syngas and the bio-oil yields. Content as the fixed carbon and volatile matter content based on the ASTM standard, and in the ultimate analysis I will measure the carbon, hydrogen, oxygen, sulfur, nitrogen content. There are some data from the previous study. The first one showed that the biochar yield decreases at increasing temperature because of decomposition of the biochar, and the syngas and bio-oil yield increases as increasing temperature. This one is a proximate analysis of cherry soil dogs at 3 different temperatures. It shows that the fixed carbon content increase with increasing temperature, but the volatile matter content decreases, so the biochar will become more stable when the temperature increases. This one also shows that the carbon content increases at increasing temperature, and the large content of the carbon is aromatic carbon, so the biochar will become more stable. And the oxygen and the hydrogen content decreases at increasing temperature. It also verified that the biochar become more stable at increasing temperature. So I can conclude that the biochar yield decreases as the temperature increases. The fixed carbon content increases with increased temperature. Also, the recalcitrant capability of biochar will increases. In the future, I will do the lab scale incubation. It's just mix the soil sample with biochar and simulate the environmental condition. And then I will, based on the carbon mineralization model, to calculate the carbon mean residence time, so that I can know the exact time of biochar staying in the soil. it's a reference. It's a reference I used, and thank you.